Bismillahirrahmanirrahim. Welcome to my channel Learn Math with Sayyid Ali. So today we will be practicing some more question on sine and cosine rule. So sine rule is used when we are given either two angles and one side or two sides and non-included angle. Here you can see that one side, right, one side, two angles and one side. So two angles and one side is given in this. So what we apply? We apply sine rule. So you have to remember the definition of sine rule and cosine rule where we have to apply. So in this case, we have to apply this triangle. And what is the question? A rectangular garden is set up as per diagram below. Lily, our landscape architect, wants to build up a fence for the side AB here. Calculate the length of this side. So we need to know this length, right? And for sine, we have solved this equation, this question with another method, dropping a perpendicular from C on this, and then we calculate it with the trigonometric ratio. But here is the easy method or more relevant method to use the sine rule, because now we learn what sine law is. So setup for the sine law is that all three apex or vertices of the triangle are indicated by capital alphabets. So all three, A, B, C, are three corners or the vertices. They are all A, B, C, capital, uppercase alphabets. And opposite to each angle, the side, this is opposite to this side is represented by small a, and that is the dimensional length of this side. So this side opposite to angle A, therefore it is indicated as A. So this side is opposite to angle B, so this will be, which is given, so B is my given, right? So we have to set up the alphabets or triangle as per our formula, right? So C is the capital, this is 83 degrees, C is capital, and the opposite to this side is smaller c. So this smaller c is unknown, which is my length of AB. And we need to know what is the length of side length AB to make it a fence, right? So architect Lily is looking for to know the side of this triangle, which is AB, right? So what is sine law? Sine law is A over sine A is equals to B over sine B is equals to C over sine C. This is my sine law, right? And in this case, I can use sine law because two angles and one side is given. So two angle and one side is given. Whenever two angles is given, obviously we can find out the third angle, because the sum of all the angles of a triangle is 180. So we can subtract 180 minus 22 plus 83, and I can find out measurement of angle B. So my measurement of angle B is equals to 180 minus, when we add these together, it's 105. So my measurement of angle B is, how much is it is? 75 degree. So I also know the third angle. Whenever I have two angles, I can find out the third angle of a triangle by subtracting the sum of the two angles from 180. That we'll know, right? So now we know all three angles. So this is now easier question, because we can use the sine law easily. Which two terms we have to take, because these are the three sides and three angles. But here I have to know this C. So I have to use this obviously with this, and known side is 31. So that means this I have to use. So B and C angle I will be using. So this part of the equation I will be using, not the whole thing, right? Because we have 6 variables in a triangle, right? And we can find out all 6, but here we don't need to. We are only requiring AB, side length AB, right? So what we will be using? B over sine B. What is B? B is 31 divided by sine B. What is angle B? 75 is equals to C. C is unknown. Divided by sine of 83. Good. Everything is good. Unless, right, up to the point when we express our triangle in terms of my formula, then everything is easy, because we need to know these capital angles like A, B, C, capital alphabets, and then relevant side. So which side is C? Opposite to the angle C. Which side is A? Opposite to the angle A. Which side is B? Opposite to the angle B. This need to figure it out correctly, right? And this is the basic of this formula or this triangle, right? So now we have this and we need to find out C. So we can cross multiply easily, right? So we say C times sine 75 is equals to 31 times sine 83. So C times, right? So C will be equals to, this sine 75 will go and sit in the denominator because it is multiplying over there. So sine 75 will be here. We have to substitute the values of the sine from calculator. So 31 times sine 83, which is 0.99. You can take 0.993 maybe, right? So divided by sine 75. So I rounded off to 3 decimal places. Sine 75 is 0.966. I rounded it off as well. And now I have to multiply the top like numerators, and then I have to divide it, right? So when I do this math, this is 30.783 divided by 0.966, which is equals to 31.8, which we can say that 32 meters. So that side length AB is 32 meters, which need to be fenced by the architect, right? So this is how we can do it. The previous solution was dropping a perpendicular was also right, and you can match the answer. In both cases, we got the same answer, but this one is easier in the way that we have to do less work because we know the relationship between the side and the angle, So when we are given two angles and one side, two angles and one side, or two sides and non-included angle, we use sine law. When we use cos law, cosine law or rule is used when we are given either three sides or two sides and the included angle. So we can have more questions on this. I hope you understand this thoroughly, but be careful while you put the subscript small alphabets A, B, C, which is indicating the side length of a triangle opposite to the angle. So angle A will be the smaller A here. Angle C, so the smaller C. Angle B, so the small. Whatever the vertices of a triangle, if it is P, Q, R, then in front of the P is the smaller P. Q, here will be the smaller Q. R, here will be the smaller R. So if you put the subscript correctly, then you can use the law correctly. A over sine A is equals to B over sine B is equals to C over sine C for any non-right angle triangle. Hope you like the video. If you like it, subscribe my channel, press the bell icon button to receive another video. Thank you for watching.